Okay, so let's talk about this conrotatory and disrotatory ring closure reactions, right? This is really interesting thing about these pericyclic reactions. Now we have talk about the introduction and basic concepts of these pericyclic reactions, right? If you have not watched that video, I will put the link here. You can watch it. And the main thing about this pericyclic reaction is there are few theories, which is like Heukel theory, frontiorbital theory. Likewise, we are going to talk about this Heukel theory in our next video. So this video, like here, we are going to talk about this conrotatory and disrotatory ring closure in electrocyclic reaction. So basically, this would be a foundation to our next big video, which is about the Heukel theory. Now, to discuss about this conrotatory and disrotatory, these things, let's take an example, right? So here we have a reaction. So this is a ring closure reaction. So as you can see, this is our alkene, and after the reaction we have a structure like this. Okay, now you can see the ring has closed. Now there are several ways that we can assume the reaction can take place. Now if I draw a more detailed structure, right, with the orbitals like this, yeah, now these are p orbitals. Now there are two pi bonds like this. Now what happens is when we go from here to here, you can see these two bonds are going to be broken and new bond will be formed between this orbital and this orbital, new pi bond. Now another new bond, a new sigma bond will be formed between these two carbons. Now there are main four ways, right? There are four main ways that this new sigma bond can be formed. The first way, okay, the first way is that this orbital, right here, look at this orbital and this orbital, these two are gonna overlap with each other. Like this part, the top part, right, this top part is going to overlap with the top part of the other orbital, so we call this as top overlap. And the second way is, this is the first way, and the second way is that this top of this orbital can go and overlap with the bottom of the other orbital, so we call as top bottom. And the third way is that bottom top, like this bottom part of this orbital can go and overlap with the top part of this orbital, so it's bottom top. And the final way is the bottom bottom. So like this bottom part of this orbital will come and overlap with the bottom part of the other orbital, so it's bottom and bottom, right? Now let's look at this each of methods to see like how we can arrange that each of these ways into conrotatory or disrotatory, right? Now if I take the first method, or otherwise this first part, which is the top, and in this case what you will see is here you have the structure. Now these are the two orbitals which will play the crucial part. Now in this case you will see that the top of this orbital will come and overlap with the top of other orbitals. Now in order to do that, right, in order to overlap top kind, right, you have to rotate this orbital in right hand direction, while you have to rotate this orbital in the left hand direction, right? So you can have this orbital in this position and you can have this orbital in this position, so you can have the overlap. Now in this case you will see that we have rotated this particular orbital in the right hand direction, while we have rotated this orbital in the left hand direction. So the rotation, right here, the rotation is opposite, right, here right, here left, the rotation is opposite to each other. So when you have the rotation opposite to each other, we say it's disrotator. And when you have a rotation same, right, in both orbitals you have the same kind of rotation, in that case you call as conrotatory. Now if I take an example, let's let's go to second one, right? Shall we? Let's go to the second one. So in second one is top bottom, right? In this case, what happen is here this top will come and join with this bottom. Now in order to do that, right, you have to rotate this orbital in the right hand direction, while you have to rotate this orbital in right hand direction. Like if you rotate this orbital in the left hand direction, you will have the overlap of top. Now you have to overlap this part with this part. Now to do that, you have to take this part to this position. So how we can do it? You have to rotate this orbital in the right hand direction. So here we have right direction. So both of the directions are same. So in that case, we call it as conrotatory. This is conrotatory. Okay, this is conrotatory. Now let's take let's take the third one, which is, let's see, I think bottom top. Yeah, bottom top. When we look at the bottom top, let's see how we can arrange the bottom top and how, in which direction do we have to rotate each orbital in order to come up with the bottom top overlap, right? So bottom top means we have to overlap this part with this part, right? So basically what you have to do is you have to take this orbital into this position. Now you can see that the rotation direction is left hand, right? We have to rotate this orbital in the left side. Now you have to take this part to here. So basically this orbital, it's the same, right? It has to rotate in the left hand side. So this is also left. Now this is same side, right? You can see the same rotation happens in the both orbitals. So this is conrotatory. Now in the last case, we have the bottom. Right, in this case what happens is let me erase this. You have to overlap this part with this part, right? So you have to take this one here and take this one here. Let's see the rotation. Right here, the rotation is the left hand direction. So this is left hand direction. So rotation here, it's right hand direction. So the rotation is opposite to each other in both orbitals. So we can call this as disrotator. Right? This is disrotator. So this is basically the concepts in conrotatory and disrotatory. So if I summarize our discussion, right, we will talk about the example too, right? So just for the concept sake, top overlap is basically the disrotatory. Top bottom is basically conrotatory. Bottom top is also conrotatory. And finally bottom is basically disrotatory. Now let's discuss a small example, shall we? Now let's take a structure like this. Now my question is, right here, what I'm going to do is you have to draw the structure and mention the specific pathway, like whether it's conrotatory ring closure or disrotatory ring closure, right? So I'm going to say like this is conrotatory ring closure, right? So this is conrotatory ring closure. You have to propose a structure, right? 3D structure, right? 3D structure whether these two methyl groups are coming out of the plane or going into the plane. That's the part. So if I state that this particular reaction goes through the conrotatory ring closure. Conrotatory means these two orbitals, right? These two orbitals rotate in the same direction. So let's say both are rotating in the left direction, right? Here both are rotating in the left direction. Now what happens is, when this orbital goes down, right here, when this orbital rotates into left hand direction, you will see this methyl group. This methyl group is on the plane, right? It's on the plane. Now when this orbital goes to the left, you will see that this methyl group, it goes into the plane, it goes down. Now when this orbital goes to the left, right, this methyl group, it comes up. So this methyl group, it goes into the plane, while this methyl group, it goes up to the plane. So final structure would be, right, here we have the ring closure, while here we have one methyl group goes into the plane, while the other methyl group coming out of the plane. So you can propose the other way around too, right? So here I have taken the left hand side as the connotator ring closure, or it can be right hand side, right? Both can be acceptable. And what if I say that you have to draw the structure for the disrotatory? What can you say about the disrotatory ring closure? What would be the structure? I need you to try it yourself. So if we are talking about the disrotatory ring closure, right? Disrotatory means this opposite direction. It's the opposite direction. Now if I consider the rotation of these orbitals, right, here it should be same direction. Sorry, it should be opposite direction. Disrotatory means it's opposite direction. Now in the opposite direction, what we have to do is, let's say we have rotating this orbital in the right hand side, while we are rotating this orbital in the left hand side. So it's opposite direction, top overlap. Now in this case, what happens, when you rotate this orbital in the right hand side, you will see that this methyl groups comes up. So it comes up to the plane, right? It comes over the plane. While when we rotate this one in the left hand side, this methyl group is also coming up the plane. So you have the final structure. It's like this. Here we have the ring closure, and both of the methyl groups, right here, both of the methyl groups are coming out of the plane. Sorry, there should be a pi bond here, right? These are the two structures. These are the pi bonds. Now here, this is the structure for the disrotatory ring closure, while this is the structure for the conrotatory ring closure. So we call this structure, as you can see, here the methyl groups, two methyl groups are on the same side, right? Two methyl groups are on the same side of the ring. So this is a cis structure. This is a cis structure. While here you can see the two methyl groups are on the opposite side of the ring. So this is a trans structure. So I hope that this disrotatory ring closure and conrotatory ring closure, you are okay with this, right? So I highly, if you have any questions, please feel free to comment below. I will try my best to answer this question, and please go through this. Like, you have to understand this very well, right? So when we come into the Huckel rule, right, Huckel theory, when we talk about the examples, these concept, this disrotatory and conrotatory ring closure, these concept will be applied, right? So in our next video, we will talk about the Huckel rule. See you then.